Hello everyone, hope you are doing all well. Welcome to yet another video of the introduction to our programming video series. So this video is in a sense very important because the topics that we are going to describe in this video is sort of ubiquitous, because the topic that we are going to cover, the R notation system, is something which you are going to use in your data analytics projects every now and then. Okay, and that's why this topic becomes so important, so that you understand it completely and you become comfortable in using these techniques. Okay, so let me start as usual with the agenda. So in this video we are going to describe what this R notation system is. Then we will see how we can use the R notation system. First we will define what is R notation system, then we will see how we can use the R notation system. There are 6 types of R notation systems defined in R, so we are going to see one after another. We are going to see all of them. Then we are going to take simple examples so that all this. Then we are going to take a simple example to describe each of this type of R notation system, and finally we are going to implement everything that we have learned in the video on the R code, on actual R code. So make sure that you stick around in this video till end so that you understand the concept thoroughly and you become proficient in using these R notations in your project. Okay, so let me start with our first point of agenda. What is R notation system? So what is R notation system? R notation system helps you to extract value from R objects, okay, or to retrieve the value from the R object. And this technique of extracting the value from R object is also known as subsetting. Okay, this is also called as subsetting. Okay, now you may wonder why I would like to extract the value from the R object. So for example, if you don't want to work on the entire data set, if you want to work on a part of the data set, okay, or if you want to modify the part of the data set values, then you want to extract that part of the data set on which you want to work, right? You want to subset that part of data set. That's why it is called as a subset. So if I were to use a set notation, then this whole circle becomes your data, and this small part which is inside this circle, this small part, it's called as a subset of the data, right? And in this video we are going to talk about this part, how we can able to retrieve out this small subset of this data. Okay, that's what the intention of learning the R notation system, right? So before we delve into further details, let me tell you in a very rude way how the data is stored in memory. Okay, so for example, if I create a R object called myvector and I assign some values here. Okay, so this is my vector object And in a similar fashion, if I create data frame, which will have two columns, column 1 and column 2, and I will use the same values here, 10, 12, 20, 30, 40. Okay, now these are the two objects that I have. One object is a vector, another object is a data frame. Now let me tell you in a very crude way, it's the most simplistic way that I'm telling you how this gets stored in memory. Okay, so once you create this objects, what R will do, R will assign some part of memory location to this vector or to this data frame. Okay, and it will divide that memory location into parts. Okay, into small parts, and each part will now store the value of your object. Okay, so you have 4 parts because you have 4 length of this object is 4. So, and each part will store a value. Each small part of that memory will store a value. Okay, and in similar way, though it looks like a table, but in memory the table doesn't get stored in the same fashion. It also gets stored in a linear fashion. So here the data frame will also get stored in the same way as a vector. Okay, but now the important part is that each of this value will have a index position. Okay, so 10 will have index position of 1, 20 will have 2, 30 will have 3, 40 will have 4. And index position, the index position is the same as the index position you mentioned while creating the object. Okay, and why it will start with 1 and why it not with 0? Because in R the first index position starts with 1. So let me write this important part. In R, first index position starts with 1. Okay, starts with 1. So this is very important. It's not with 0. Unlike in C or C++, you have the index position starting with 0, but in R it starts with 1. So that is one important thing to be noted. Okay, now if I come to the data frame, in data frame I will be having 2 index frames, index values. The one index value is for a row and another index value is for the column. Okay, and therefore for 10, in order to describe 10, R will use 2 index positions here. Now 10 is belong to the first cell. The first cell means the row number 1 and column number 1. In a similar fashion, 20 is now belong to the second cell, which is first row and the second column. Similarly, for 30 it will be the second row, first column, and for 40 it will be the second row and second column. Okay, so can you now see the difference in the index positions, the way it is getting indexed in the R memories? If you have a simple vector, it will be a simple number index position, but if you have a data frame or a matrix or a list or any, to that matter, multidimensional array, then you have the rows and the columns as the index position for that particular value. Okay, so that's how, it's a very crude realization of how this data gets stored in a memory. There is a lot many things that happens when actual data gets written on the memory, so we are not going to go into those details, but this is how, at a very high level, this is how it's exactly happening. Okay, so now having understood this, what the R notation system is, how it's going to help us out, and how exactly the value gets stored in our memory. Now let's go ahead with our second point, how exactly you are going to extract the value from the R object. So let's see that. So how the subsetting happens, how you can able to select the values. So to select the value or the set of values from the data frame, what you have to do is you have to write a data frame's name. So this is data frame's name, and followed by a pair of brackets. So these are the pair of brackets, hard brackets. Okay, and between the brackets you will have two indexes separated by a comma. Okay, you have two indexes separated by a comma. So R will use the first index, this is the first index, to subset the rows, and the second index to subset the column. Okay, this is how it will be selecting the values. For example, you have a data frame called deck, let's see, and you want to select the value from the first row and the first column. Then this is how it would look like. The first index is subset of rows, the second index will give you the subset of columns. Both are separated by comma and they are put in within the brackets, followed by the name of the data frame. Okay, and if you want to subset a vector, okay, atomic vector, it's the same way that is used, but in this case you have a name of a vector followed by a square brackets, but now within the square brackets you only will have one number, one index position, because the vector doesn't have the columns, it only has one row. Okay, so you have a one index position. For example, I have my vector as a vector, $30, and if I I'm sorry, and if I want to extract this 20 from this my vector, then the position of this 20 will be 2. So in this case, how it would look like is my vector, and the position within the square bracket will be 2. It will give me 20 as a value. Okay, so this is how the subsetting happens. This is how you can select the values within the R object, and this type is the same for any R object. Here we are talking about data frame, but in a similar fashion you can retrieve the values from a matrices, from the list, as well as from these atomic vector that we have just seen. Okay, it's a similar notation irrespective of R object that you want to retrieve. Okay, now you have a choice of writing these indexes. Okay, and depending upon ways that you write an index, there are six different ways to write an index for R, and each does something differently. So let's see what these different types of subsetting are. So depending upon the way you write the index, there are 6 different ways of subsetting. You can use a positive integer, you can use a negative integers. Yes, you have heard correctly, you can use a negative integers, you can use 0, you can use blank spaces, you also can use a boolean values, true and false, logical values, and if you have assigned a names to a column in a data frame, then you can also retrieve those columns with the help of names. Okay, so let's see all these different ways of extracting the values one by one, starting with positive integers. So let's start with the positive integers. So I have created a small vector called myvec, and I want to retrieve this number 5. I want to retrieve this number 5 from this data, from this vector. So how would I do it? What we have seen that the notation first will start with a name of the object followed by a square brackets, and within the square brackets you will have to call the index position of this value. So what is the index position of this value? Index position is 3. So if you type up this out in the console, you will get the value as 5. And not necessarily you can only extract a single value, you can also extract multiple values. For example, if I want to extract say 11 and 23, then what I will do, I will create a small vector inside the square brackets, and this will be a position vector. So what is the position of 11 is 1, 2, 3, 4, 5 and 6. So I will create a small position vector within the square brackets, and if I run this, I should get 11 and 23. Okay, this you can do with the help of positive integers. So I've used the positive integers. Okay, and how the notation can be used in extracting the values from a data frame. So this is a data frame that I created. It has the name of the so this is a small data frame that I've created, and if I want to extract the values from say third row and third column, okay, this value if I want to extract, then I will, let's pretend that this data frame has a name called hobby is a name of my data frame, and I will then use the first index position for the row. In this case my row index is 3, and my column index also is 3, okay, separated by comma, remember. And if I run this, then I should get guitar as the output. And you can also extract multiple values. For example, if I want to extract the 1941 and flute, which I have highlighted here, 1941 and flute. So in this case, what I will do is I will again create a small vector inside the brackets. So in this case, my column position, I'm sorry, my row position will be 2, but in this case I want to extract 2 columns now. I want to extract column number 2 and column number 3. So let me write down here column 1, column 2 and column 3. So in this case I want to extract column 2 and column 3. So what I would do here is that I will create a small vector 2, 3. So this will fetch out 1941 and flute. Okay, now in this case I've used all the positive integers, that's why this type of subsetting is called positive integers. Now let's go and check how we can use negative integers for the subsetting. So now let's see how we can use negative integers in subsetting. Now please remember that negative integers do the exact opposite of positive integers when indexing. Okay, R will return every element except the elements in negative index. Okay, so let me better write it down. R will return every element except, okay, the elements in the elements in negative index. negative index. Okay, so please remember this. Now if I want to use myvec -2, what are going to show me? Is going to show me everything except the element in negative index. Here the element in negative index is 3, so R is not going to show me the 3. So 1, 5, 42, 11 and 23 is what R is going to show me. Okay, and same goes with the data frame. Here if I use hobby -3, 1, then R is going to give me the output as from the first column all the rows 1840, guitar, 1941, flute, but it's not going to print out the row number 3 because this is what I have used as a negative subsetting, and 1940 drums. So for the data frame, if I use a negative notation, say for the third row, okay, then how it's going to give me the output? It's going to filter out the third row from the first column, from this column, and it's going to show me the output. So my output would be Amit, then Suresh, and then Geeta. Okay, it's not going to print out this part Sachin because I am subsetting this -3. I'm subsetting it with negative value. So this entire third row will going to get filtered out. Okay, this is how the negative integers work. This is how the negative subsetting works. So let's now go ahead and check how the 0 can be used for the subsetting. So what's going to happen if you use 0 as an index? Now remember, 0 is neither a positive integer nor a negative integer. Okay, but R will still going to use this type of subsetting. When you use 0, R will return nothing, okay, and it will give you a empty object. For example, if I use myvec 0, R is going to give me an empty object. It's not going to return me anything. Okay, and similar is the case with the data frame. If I use if I use 0 as a data frame, then it's also going to give me an empty object. Okay, so remember, you can use 0, but there is hardly any use of using 0 in subsetting because it will only throw out the empty object as an output. Okay, so you will never use 0 for the subsetting. Now blank spaces is a more convenient way if you want to extract every value of a column or from a row of a data frame. So for example, in this case, if I want to extract all the columns, okay, all the columns with the first row of the data frame. Okay, now if I write blank space for the column index position, that means what R is going to give me, it's going to go to the first row, but since it has encountered a blank space for the column index, that means R will go to the first row and R will print the entire first row for me. Okay, because the blank space in column position means R will be printing all the columns across to that particular row. Okay, right? So in a similar fashion, if I write hobby blank space 1, what it's going to do, it's going to go to the first column, but in this case now it's going to print all the rows across the first column. That means it's going to print Amit, Suresh, Sachin and Geeta. Okay, all the rows across the first column. It's a very convenient way if you want to extract the entire row or the entire column from a data frame. That's how the blank spaces are used. So let's see the next type of R notation, logical values. Now let's see how we can use logical values to extract the data. So I've created a data frame called my data frame. It has a name of a person, the age of a person and a gender of that particular person. Okay, now if you supply a vector of trues and false, so this is a vector of trues and false, okay, as your index, then R will match each true and false to a row or column depending upon where you put this vector in your data frame. Okay, and R will then return each row or column that corresponds to true. Okay, so in this case I have put in a vector of logical values as a column index. So R will give me the columns for each true logical value for each true logical value. Okay, so if I run this, then I will get Siddharth because the first column index is true. I will get 42 because the second column index is also true, but I will not going to get a gender M. I will cross this out because the third column index is false, so R will not going to print out the gender for me. So this will be the output if I run this subsetting with boolean values in it. And similar is the case if I flip around this, then similar will be the case for the row index position. So it will print out the rows which will have true boolean value, and it won't print out the rows which will have false boolean values. So this is how the logical values are used for subsetting. Now let's go ahead and check our last type, the names subsetting. So in the name subsetting, if you have already assigned the names to your columns in a data frame, then you can simply call out those names to print the entire column of that data frame. Okay, so in this case, if I run this subsetting command, then it will going to call out the person, age and sex by the name of the columns, and it will going to give me all those values belonging to the first row. So the output of this will be Siddharth, 42 and male. Okay, so I've used the names of the columns as a subsetting in this example. Okay, but please note one thing here is that before you use this type of subsetting, you would have to assign the names to each column of the data frame. If you have not assigned the names to each column of the data frame, then perhaps you will get the error. Okay, so now we have come to the end of all the different types of subsetting. We started with positive integers, negative integers, then we saw 0, blank spaces, logical values, and we ended our discussion with names. Now let's go and open the R session and let's run some examples to check how exactly the R gives you the values from a data set. So let's open the R session. So we have created a data frame called deck. So we are all acquainted with this data frame. So in this example, I want to use the same data frame, deck.csv. So I'm calling that data frame in our environment. So I'm setting the working directory in which that data frame is currently available. Okay, and I'm storing that deck.csv data frame into card_deck data frame. So with string as a factor equal to false, which will ensure that strings are not converted into the factors. Okay, so let me run this. So if I want to have a look at few rows of the data set, then I will use head column, which will print out first 6 observations of the data frame. So it has a column name called face, suit, and it has a value, and then it will give me the first 6 entries of the data frame. So let's start with the positive integers. If I use a positive integer subsetting, and if I want to retrieve the first row and the first column, the value belonging to the first row and the first column, then I will use 1,1 in the square bracket. So here you go, it has given me king as an output, as you can see from this small subset. So it has printed out king. So if I go back and show you, so here you go, it's a king is the first is the value which belongs to the first row and the first column. So in a similar way, you can also extract multiple values. So in this case, I want to extract all the columns. So I've used a vector of column indexes 1, 2 and 3, and I want to type out the first row. So I will be using 1 as a row index position. So it has printed all the columns across the first row. So king, spades and 13. Here also it's king, spades and 13. And ASK notation system is not limited to data frame. You can also use the same syntax to select the values from the any of the R object. Now in this case, I've written created a vector, and I've used subsetting to print out the first 3 values of the vector. So it's printed out the first 3 values. Negative integers, R will return every index except the index in a negative index. So in this case, R will omit all the rows belonging to the negative index, and I will print out only those rows which will so in this case, R will omit all the rows belonging to the negative index, So if I run this, then this is what I will get. It has omitted all the rows starting from second index till all the way till 52nd index, and it has printed out only the first row of the data set. Okay, negative indexing. Similarly, R will return an error if you try to pair negative integer with a positive integer. Here I am pairing a negative with the positive. R will going to show me the error. So this is the error that you will see. Okay, we also saw the zero type of indexing, but in this case it will give me a empty object. So this zero indexing is not used, but even if you use in your so zero indexing we have used, but if you happen to use it, then it will give you the empty object. Blank spaces are used to extract the rows or columns from the data frame. So if I run this out, then since the blank space is now used for the column index, it has printed all the columns and all the values across the first row. Okay, you can also use logical values, vector of trues and false as an index, and R will match each true and false to a row or column depending where you position that trues or false vector. It will extract the values from the data set. So if I use this first type of indexing, I'm telling R to show me the values across the first row, but in this case I am going to print out only the first two columns, because the position for the third column, as you can see, is false, so it has not printed me the third column. Now if I run this second type, and if I run this second type of command, then R will going to print out every third row. Okay, because what I'm telling here is that you don't print first row, don't print second row, but you print the third row, and this will the same logic will be used across all the rows all the way down till 52nd row. Okay, so every third row will get printed, okay, as per the vector that you have put in for the row index. And since I'm telling to print only first two columns, R has printed only first two columns. Okay, so if you go down further, then you can see that it has printed every third row as per the vector of logical values that you have put in for the index row position. You can also use names. In this case, I am asking R to type out the names, to type out all the column values belonging to the name suit. So it has given me all the column values which are appearing under the name suit column. Okay, so this is how it is done. It's very important to understand how exactly the subsetting is done and which type of subsetting you want to use as per your requirement. So let's quickly recap what we have done in this video. We started with our notation system. We understood what our notation system is, and we also at a very primitive level understood how exactly the R stores its objects in a memory. Then we saw different R notation formats: positives, negatives, positive integer, negative integer, zero, blank spaces, logical values, and names. And each of these R notation format can be used according to your requirement, which type of data you want to retrieve and how you want to retrieve it. There are six different ways of R notation, and we ended our video by looking at some of the examples in our session. So in this video, remember, we only saw two types of our objects. Okay, we saw how the subsetting is done on a vector and how the subsetting is done on a data frame, and similar logic you can also use for matrix also. Okay, but we have not discussed in this video, we have not discussed the subsetting for list. So in this video we have not discussed anything about the list, how the subsetting for list is carried out. So in next video we are going to talk about how the subsetting for the list is carried out, and at the same time we will going to discuss a very important notation system called as a dollar operator. How this dollar notation system is used for the subsetting. So this will be the part of my next video. Okay, so do tune in. If you have not subscribed to my YouTube channel, you may do so by subscribing to a channel called The Infinity, a channel for data science. And of course, if you want to get the immediate notification of all my videos, then you can also hit a bell icon. Okay, so that you will get updated of all the videos that I post on YouTube. So thank you very much. Thanks for watching this video. Bye bye and take care.